Hey everyone, welcome back to my number sense series. In this video, we're going to be talking about the divisibility rule for 11. And in my opinion, this is one of the coolest divisibility rules that's out there. And it operates according to a similar principle as our divisibility rule for 3 and 9, which is decomposition. So let's say we're given a number, 7,419, and we want to determine if this is divisible by 11. Or actually more generally, we want to determine if this what the remainder of this number is when you divide it by 11. And this is more general because being divisible by 11 just means you have a remainder of 0. But if we also get the other remainder, the remainder when it's not divisible by 11, this could give us more information about the number. In fact, number sense is sometimes going to just straight up ask you, what's the remainder? Not, is it divisible, of course. So how can we find the remainder? Well, let's decompose. So this would be 7 times 1,000 plus 4 times 100 plus 1 times 10 plus 9. But we can't just do 999 plus 1, 99 plus 1, 9 plus 1, because that relied on 999, 99, and 9 all being multiples of 9 and letting us cancel those out. So we can't do that. But we can do something else, because 11 is also a special number. Notice that 10 is 11 minus 1. 100 is 99 plus 1. And 1,000 is 1,001 minus 1. So maybe you can see how a pattern similar to that of 9 develops here actually. Because 1,001 is a multiple of 11, it's 7 times 11 times 13. 99 is a multiple of 11, and 11 is a multiple of 11. So, if this is equal to 7,419, which it is, we should be able to subtract any multiples of 11 that we want and preserve the remainder when we divide this number by 11. So let's subtract our multiples of 11, because this 7 times 1,001, that's a multiple of 11. So if we get rid of that, it's actually just 7 times negative 1. If we get rid of this 99, we actually just have 4 times 1. If we get rid of this 11, it's actually 1 times negative 1. And this is still 9. So maybe you see the pattern emerging now. Whereas with 9 and 3, we would just sum up all the digits. Here we're actually alternating addition and subtraction. Plus, minus, plus, minus. And this is the trick for 11. Now you have to start adding at the right end of the number. Don't start just adding or subtracting over here, because the number of digits that the number has will determine if this is a plus or a minus. But this, the right end, the very last number, is always going to be a plus. So the trick is, if we sum all this up, we get minus 7 plus 4 minus 1 plus 9 for a total remainder of 5. So the way you would execute this trick on this number is you would go plus 9 minus 1 plus 4 minus 7. Plus 9 minus 1, that's 8, plus 4 is 12, minus 7 is 5. And that is how you determine the remainder of a number when it's divided by 11. And then, of course, if the remainder is a multiple of 11, such as 0, 11, 22, negative 11, negative 22, then you know that the original number is also a multiple of 11. So let's try it out. For example, 61415,926. Maybe recognize this as just pi, but the 3 is replaced by a 6, and you'll see why I replaced it with the 6. Because, let's do our trick here. So it would be plus 6 minus 2 plus 9 minus 5 plus 1 minus 4 plus 1 minus 6. And a little thing you can do here is kind of just take it 2 at a time. You can do plus 6 minus 2, and you think, oh, okay, plus 6 minus 2, that's just 4. So it's going to be like 4 plus, okay, well, what's plus 9 minus 5? That's also 4. So it's like 4 plus 4. Basically, you're like grouping. So then what's plus 1 minus 4? That's minus 3. What's plus 1 minus 6? That's minus 5. And what you get here is plus 4 minus 3 minus 5, which is 0. And of course, in number sense, you can't write all this out, but if it helps you to kind of like group these in your head, you can definitely do that. And so what we get is 0, which is the remainder when we divide it by 11. And if something has a remainder of 0, then of course it is divisible by 11. Nice. Now next question, 271828. Maybe you also recognize this as E. But let's try our luck and see if this is divisible by 11. So we have plus 8 minus 2. Okay, plus 8 minus 2 is 6. Plus 8 is 14. Minus 1 is 13. Plus 7 is 20. Minus 2 is 18. And we see that we have 18 here. So this has a remainder of 18 when we divide it by 11. No, the remainder is not 18. Because you can't have a remainder of something that is greater than the number you were dividing by. If we have a remainder of 18, what it's really saying is that we have a remainder of 11 plus 7, which is just a remainder of 7. So this number has a remainder of 7 when we divide by 11. And also, since 7 is not equal to 0, this is, of course, not divisible by 11. Okay, last question. Once again, same idea. Let's do our plus minus plus minus plus minus plus minus. So plus 2 minus 5, that's going to be minus 3. Plus 8 is plus 5. Minus 9 is minus 4. Plus 3 is minus 1. Minus 8 would make minus 9. Plus 4 would make minus 5. And then minus 6 would make minus 11. Or a remainder of negative 11? Also no. Once again, we can't have a negative remainder. But wait, a remainder of negative 11, that's just a remainder of 0 minus 11, which is a remainder of 0. And since it's a remainder of 0, we know that this number is also divisible by 11. And so once again, this is kind of just saying that if the remainder is a multiple of 11, any multiple of 11, then your original number is also a multiple of 11. It's divisible by 11. So that is the divisibility trick for 11 that we can also extend to just find the remainder when any number is divisible by 11. If you didn't understand the proof I did during this video, that's okay, because it is also very unrigorous. And I'll give a rigorous proof in a bit, but this is a very unrigorous proof. But if you did not understand that at all you have to remember is plus, minus, plus, minus, plus, minus, plus, minus, and that's it. So I hope this video was helpful to you guys. I think this divisibility trick is really, really cool. And yeah, I hope that helped you guys. Thank you guys so much for watching, and I'll see you next time. And now for the bonus, which is actually proving this rule, because I think this rule has a very beautiful proof. So to do this proof, we are going to have to do something called taking the number mod 11. So I'll just use this number for example. 7419 mod 11. Now really, me saying mod 11 isn't doing anything different, but this is kind of convenient. It's convenient language. Mod 11 just means I want to find this number. I want to find the remainder of this number when you divide it by 11. So, same thing, different words. Now, if I decompose, I get 7 times 1,000, 4 times 100, 1 times 10, and 9. And the thing you should notice here is that these are powers of 10. Of course, they're powers of 10 because, we work in base 10. And powers of 10 are very special because 10 mod 11, that's actually congruent to -1 mod 11. This is just like how if you say this number has a remainder of -1 when you divide it by 11, well, you wouldn't really say that, but that's mathematically equivalent to saying it has a remainder of 10 when you divide it by 11. 10 equals -1, or 10 is congruent to -1. Then, this is 10 to the power of 1, this is 10 to the power of 2, this is 10 to the power of 3, right? So, the next thing we do is raise this 2 powers. So we get 10 squared is congruent to -1 squared mod 11. But -1 squared is just 1. Similarly, 10 cubed is equal to -1 cubed mod 11, but that's just -1 mod 11. 10 to the 4th equals, or is congruent to 1 mod 11 once again, you can see how this pattern continues. And this is, a proof, because no matter what power you raise -1 to the power of, it's always just going to alternate, flip between -1 and 1, -1 and 1. And so this is why we get that +1 - 1. You can see here that this 9, here it's 10 to the power of 0 is congruent to 1 mod 11. And so this is just 9. But 1 times 10 becomes actually 1 times -1. 4 times 10 squared becomes 4 times 1. 7 times 10 cubed becomes 7 times -1. And if we were to, extend this to this over here, we see that this 1 times 10 to the power 4 becomes 1 times 1. 4 times 10 to the power 5 becomes 4 times -1, and that is where we get the alternating. So you can see, once again, plus, minus, and this arises from the fact that 10 is congruent to -1 mod 11, and -1 flips between negative and positive when you take it to the increasing powers. So that is actually the proof, and I think it's a really cool proof. So if you stuck around for this proof, thank you guys so much for watching. I hope this is interesting to see. And for the second time, I'll see you next time.